There's a stats past paper question from the CCEA paper from February 2022. Now this is just a practice paper and this is one on hypothesis testing involving the normal distribution. So this is question 8. Let's take a wee look at what they have. So the company who makes Crunchy Crisps states the mass of the packets of crisps are normally distributed with a mean of 25 kilograms and a variance of 0.36. Patrick buys 2 packets of crisps. Find the probability that each of these packets of crisps has a mass of greater than 24.5 kilograms. So we want so he buys 2 bags of crisps. We're going to work out the probability of 1 and then effectively times it by itself, and that would square it. So where it says the mean is 25, so my mean is going to be 25 here, and then the 24.5 here, and we're looking then for this area here. So we might need to work it out backwards, but that's okay. So probability then Z is greater than 24.5 minus 25, and the standard deviation then, sorry, the variance is that, so if you want to get the square root then of 0.36, hopefully people know it anyway, just to show you it, is then going to be 0.6. I have that, so my Z value then, Z is going to be greater than minus 0.8333. This is kind of quite awkward to work out. So we're looking then for the area 0.8333, because that's going to be the same whenever you flip it the other way around. That's the same then area that we're trying to work out from there. So let's get as accurate a thing as we can here. There's 0.83. So that's 0.7967, and if we're adding 3 to it there, we would be adding 8 onto the 67, but we're actually going to be slightly more accurate, so we're going to go a third of the way then between 3 and 4, because it's 833, so I'm actually going to add on then 9, so 0.79 adding 9, so 0.7975 I think will be an accurate enough value then for us. So that's the probability then of 1 bag of crisps being like that. For 2 packets of crisps then, squared is 0.636. We have that. Trevor buys these crisps and starts to suspect that the mean mass of the packets of crisps is less than 25 kilograms. 25 kilograms. Okay. So I'm just spotting out that that's kilograms. That's a fairly heavy packet of crisps. Wanted to mean grams, but that's okay. Decides to test this hypothesis using the significance level of 5%. He takes the random sample of 35 packets of crisps and calculates the mean of the sample to be 24.8. Complete the hypothesis test. So we want to check and see then if it is indeed 25. So we're going to take our null hypothesis is that mu is going to be 25, and then we reckon it's lower than that, so we're going to do a one-tailed test, and our H1 is then going to suggest that it's less than 25. So of course we need to write these. So H0 is that mu is 25, and H1 is that mu is less than 25. We're going to test it at the 5% level, of course, and that is then going to be a one-tailed test. And then we're going to reject H0 at the 5% level. So reject H0 if Z is less than, and these are fairly standard results, but you can kind of get them from there. If you look at your 95 here, let me see where it would be, 5 and add the 5, so 1.6 0.945, but again that's a number you should be familiar with anyway with doing a few of these questions. So 0.9495, we're trying to make it up to 0.95 for the 5%, so we need to add 5 onto that, so it's 1.645. 1.645. Alright, so here's what we have. Our weight is distributed normally, and my mean, which is mu, is 25, and my standard deviation then is 0.6, and we're going to try and find the probability though the weight is less than 24.8. So our wee diagram then is going to look like this. That's 25, and then that's going to be our 24.8 there, and we're trying to find out if that then is in the bottom 5%. So remember, we have a slightly different formula for this. Because it's a sample. And so from there, so 24.8, take away 25, all over 0.6. Our sample size, I believe, was 35. So that's obviously that. And then the answer divided by, let's stick a bracket in here just in case. 0.6 divided by the square root of 35. That's minus 1.972. So obviously then we were looking for it to be less than minus 1.645. So since minus 1.972 is less than minus 1.645, there is sufficient evidence at the 5% level to reject the null hypothesis. And the mean weight is 25 kilograms, again heavy for a bag of crisps. And accept the bag's mean is less than 25 kilograms. It is always a bit of a rigmarole writing this out, but you want to write it out referring to your statistics and also referring to the original question. So do talk about the mean weight of the bag and things like that.